This section of learning the web might be called basic database management, but databases themselves can be rather complex and difficult to learn, so before we even start looking at any of the required code or any of the syntax you may need to know for web development, it's probably first to look at the basics of even designing a database. So this is where we shall start. So say for example we have a car rental company. For a car rental company you may want two data structures. You may want a data structure for drivers, like so, and you may want a data structure for cars, to store all the cars you own. So once again we will create two data structures, driver and car. Now one thing you may notice is it's fairly simple to start off with, and these things that we have here we shall call them from tables from now on, as that's what they're called in databases and SQL. So we start off with a database. Now we want to store information about the specific cars we have, we want to store information about the specific drivers we have. So what information we could possibly store is we could store, for example, the driver's name, the driver's age, what type of license, how long he's had the license, and that'll probably do for the moment. And for cars we might want to store information such as the type of car, the registration number, the colour of the car, and how much fuel it has. And as you can see we have like several fields in these two tables now, but it's not looking like much of a database at the moment. And one thing that you need to know about databases is the fact that they always store additional information alongside these, much like any other programmer. Like these items here, these fields, they have types. So in terms of SQL, if you want to store a name, well normally you'd store name as a string, but in SQL you'd store it as a varchar, and we'll give it a number of properties it can hold. So this is the number of characters a varchar can hold. So we'll say for a name about 40 will do. For age, well, much similar to non-programming languages, you'd use a int. For type, well, we can use a boolean, or we could use just another varchar. And date of issue, we could use a date type, so just date, time, or just date by itself. And similarly for this side, well, varchar sounds good, so we'll just use a varchar 20. For the type of car, the registration number, well, that can be a combination of letters and numbers, so we shall use a varchar, and we'll give that one 40 just to be on the safe side, even though that's way bigger than it needs to be. Once again, these are the kind of things you need to figure out for yourself when you're making your own website and databases, to figure out what size you need to be to try and save space here and there. Colour, once again, can be a varchar. And a tank, well, we measure it in litres, which is a number, so we'll just use an int. And there we go. But you may be thinking that if we're making a car rental company, well, people want to rent the cars, don't they? So how can we exactly handle that? Well, we need some way to link a driver to a car and a car to a driver. So one question you should always ask yourself when making a database is, which way is it going? Does the driver rent a car? Does the car get rented by the driver? And it changes depending on what you're doing and what type of database you want. But in this case, well, it's obvious that a driver rents a car. So how can we represent this in terms of the database? Well, one way of doing it would be to create a field inside the driver and call it car rented. And here we can store a true or false, saying if the person has rented a car. But one problem with this is, well, what happens when that person stops renting the car? Well, all of a sudden we have the issue now that we don't have any record of this car ever being rented by that person the moment he stops renting it. So this is when we start adding new tables. So for example, we might want to add a new table and call it rented record. And now you can see the database is already starting a little bit bigger. And then in the rented record we want some way to link the driver to the car. But you may notice that we have a bit of a problem on the driver's side, that there's no unique field. Like, for example, drivers might share the same name, they can share the same age, same type of license, and they could even share the same date of issue. So the driver itself isn't a particularly good example of a table. For one, it's not something called atomized. Atomized is where you've broken down every field into its smallest possible value where it still makes sense. And one example of this here is the name. So one reason you might want to break the name down into first name, middle name, last name is, well, what happens if somebody gets married? What happens if somebody gets their name changed? You don't have to change the entire record of name just to change their second name. So one thing you want to do first is create two fields, first name and second name. First name, second name. And similarly, these will both be varchars, but as I mentioned earlier, we still have the problem is there's no unique identifier for the driver. So if we think about it, we can come up with a field which will appear to be unique, and in this case it will be driver license number. Every driving license has its own unique number, so we can use that as an identifier for all driver type objects. And now we have something that links uniquely to drivers, and we have something that uniquely to cars, and now we can finally start populating our rented record. So we'll want two keys. A key is any field that uniquely identifies a record, and a record is like a unique instance of that object. So a driver license will be a record of driver. So we have two keys in here. We shall have the driver license number and the reg number from car. Now, whenever we create a new rental record, this will be a unique record that identifies one instance of a driver renting a car. So you can look closely. When a driver rents a car, we shall take their driving license number, place it into this new record, take their registration number, place it into this new record, and then we shall have a constant record which gets updated frequently with every new rented car. And this way we can look back into the database at any point and figure out who rented what car, and we can even put a date of rent. And now you can see we have linked these two tables together via a new table. Now these two keys here, it seems we are using two separate keys. This is now called a composite key. A composite key is when a new key is created by the combination of two separate keys, and this is often to essentially link two tables together and create records. Now the main reason you'd want to do this is because, say for example, one person wants to rent many cars. Now we can create this table here and create records in this table, and this person can now rent many cars over a longer period of time. While if we kept it the old way, that person would only rent one car at a time, or they'd only be able to rent one car, and then when they stop renting it, that record would cease to exist. And this is why you want to attempt to atomize your elements. Make sure that every element within that table relates to the key and nothing but the key, to ensure that you have the most suitable table which does not create duplicate elements, and attempt to break it down into the smallest possible factors so that you can see a clear connection between all of the tables and ensure that they are working correctly and that the tables make actual sense.